SolidWorks for 3D and 2D drawings, and MATLAB and C++. I have research in core technology. I am from Pakistan and I live in Lahore. Now, could each of you please introduce yourself one by one? Hello, can you hear me?
Hi everybody. Assalamu alaikum. Good evening. It's Muhammad Asif. I'm also from Pakistan, Lahore. I'm a safety professional. Thank you.
Can you hear my voice clearly? Please tell me. Okay. So I start my topic. My topic name is Introduce Energy Engineering. What is energy? Energy is the ability to do work or produce change. Exists in various forms such as kinetic energy, potential energy, thermal energy, and electromagnetic energy, and can be transferred between objects or converted into different forms. Energy is essential for all living beings and is required for our physical process and chemical reaction to occur. We know that energy is very important for us. For example, moving a car, moving a truck, running a child, or anything. Okay. The law of conservation of energy. Uh, this law states that the energy cannot be created or destroyed. It can only transfer one form to another form. Means the total energy remains constant, no change. For example, when a ball is dropped from a certain height, the top of its fall, it's it has potential energy due to its position. Has its force, this positional energy is converted into kinetic energy. Okay, the kinetic energy of motion at the moment of impact, R of its potential energy has been converted into kinetic energy, but the overall energy remains same. Energy cannot be, because we know that energy cannot be created or destroyed, only change one form to another form. Okay, the next is types of energy sources. Two types of energy sources very important: renewable energy sources, non-renewable energy sources. What is renewable energy sources? Renewable energy refers to the energy derived from the naturally replenished resources that are continuously available or are renewed at a sustainable rate. Mean renewable energy resources are derived from the naturally. For example, if we see that solar energy, solar energy mean solar energy is obtained from sun radiation and can be converted into electricity or used directed from heating and lighting purposes. Photovoltaic cell and solar thermal systems are common technologies used to harness solar energy. And next is wind energy. Wind energy is generated by the kinetic energy of moving air masses, wind turbines, wind energy into electricity. which can be used to various application, for example, including powering house, business, and utilize. And next, hydroelectric energy. We know that hydroelectric energy is produced by harnessing the gravitational force of flowing or falling water. Hydroelectric power plants use dams and turbines to generate electricity from water stored um, flowing in rivers and streams. And next, biomass energy. Biomass energy, we know that derived from the organic materials such as wood, crop, agriculture waste, organic waste, and it can be converted in biofuels and electricity generation. And next, geothermal energy means it is obtained from heat stored within the earth crust. It can be harnessed through geothermal power plants, which utilize steam or hot water from underground. These are examples of renewable energy sources. Solar energy, wind energy, hydroelectric, biomass, geothermal, are we use for generate electricity. All diseases are naturally occurs. We uh, we get again and again. And next, non-renewable energy sources. Non-renewable energy sources are finite resources that are formed over millions of years and cannot be replenished within a human. Mean when we use these fossil fuels, nuclear energy, so we cannot again get. Uh, you can see two examples of non-renewable energy sources: first fossil fuels and then nuclear energy. Um, okay, then uh, I tell you first what is fossil fuels. Fossil fuels are hydrocarbon-based energy sources forming from the remains of ancient plants and animals buried underground over millions of years. And then three types of fossil fuels. Number one, coal, oil, natural gas. So introduce some line of coal. Coal is a combustible black or brownish black sedimentary rock composed mostly of carbon and hydrocarbon. We use coal for produce electricity as well as oil. What is oil? Uh, Oil, a liquid fuel, fossil fuel composed of hydrocarbon compounds extracted from underground. Oil is refined into various products, including gasoline, diesel, and heating oil, and is used for transportation, heating, and manufacturing. And natural gas, consisting mainly of methane and hydrocarbon. Natural gas is used for heating, electricity generation as well. And second example is nuclear energy. So, what is nuclear energy? Nuclear energy is generated by nuclear fusion reactions, where the nucleus of an atom is split into smaller fragments, releasing a large amount of energy. So, these are non-renewable energy sources. Uh, Mostly coal is very used for generate the electricity, but due to these fossil fuels, due the uses of fossil energy and nuclear energy, environment impacts created because uh, when burn the coal, fossil fuels, or nuclear energy, then emit the nitrogen oxide, sulfur oxides, carbon oxides, and into the environment and impacts our environment. Uh, so I tell you first impacts create into environment when release. So greenhouse gas emissions, air pollutions and land disturbance, resources depletions, or nuclear waste. And next is importance of energy efficiency in energy engineering. So what is importance of energy efficiency into the energy engineering? Okay, so first we define this. Energy efficiency refers to the ratio of useful energy output to the total energy input in a system or process. It is measure of how effectively energy is utilized to form a desired function or task. Energy efficiency is paramount in energy engineering for several reasons. For example, first is resource conservation. So resource conservation mean uh, improving energy efficiency, reduce the amount of energy requirement to accomplish a given task, thereby conserving finite energy resources, minimizing environmental impacts associated with energy extractions, productions, and consumption. Second is cost savings, how we can reduced energy consumption, utilize bill and operating expenses for business, industries, and households. And next, climate mitigation. Okay, so climate mitigation mean reduce greenhouse gas emission associated with energy production and consumption. By using energy more efficiently, societies can lower their carbon footprint and contribute to global efforts to limit global warming and transition to low carbon economy. And energy security, improving energy efficiency enhances energy security by reducing dependence on imported energy sources and mitigating risk associated with energy supply descriptions, price as well. And economic efficient industries and businesses are more competitive in a global marketplace as they can lower production costs, improve productivity, and enhance product quality while reducing environmental impacts. Okay, then next is how we can improve energy efficiency and what the strategies we apply and we can improve the energy efficiency. So first is energy audits. Uh, I explain one by I explain each only one line. Okay. So first energy audits, conducting energy audits to assess energy consumption patterns and saving opportunities. Energy efficient technology. Investing in energy efficient technology, equipment, and appliances that meet to exceed or exceeds energy efficiency standards and certifications. And the energy management system mean implement energy management systems and automation technology to meter control and optimize energy use in buildings, industrial processes, and transportations fleets. Policies and policies and regulation. Uh, Very important. This policies, standards, and regulation at the local, national, and international level too. In uh, to use energy savings, drive market transformation, and promote best practice. And financial incentives, providing financial incentive, rebates, tax credits, or etc. Research and development, investing in research, development, and innovations to advance energy efficient technologies, improve performance, and reduce cost over time. Challenges relate to our behavior. Okay. Next topic is sustainable energy technologies. Sustainable energy technology is very important for every country. Uh, because when we use the maximum sustainable energy technologies, then less release the emissions into the environment. For example, sulfur oxide, nitrogen oxides, carbon monoxides. Because when we can not control these emissions, then our environment change daily by daily, and impact our health, rivers, plants, and each and everything, each and every living things exists into our earth. Okay, then uh, what is defined? Sustainable energy technologies are innovative solution designed to harness renewable energy source, enhance energy efficiency, minimize environmental impacts, and promote sustainable development. This technology play a crucial role in transitioning towards a low carbon and resilient energy future. Okay. So next is, for example, this example of sustainable technologies we use and minimize the emission into the environment. Solar photovoltaic system. We discussed before what is solar voltaic system, but again, I repeat. Solar PV system converts sunlight into electricity using photovoltaic cell. For example, a rooftop solar panel installed on residential or commercial buildings. These systems generate clean electricity directly from sunlight, reducing on fossil fuels and lowering carbon emission. We see that almost maximum installation of PV. We know this system is expensive, but uh, free from pollution. Okay, next, wind turbines. So again, we repeat, wind turbine capture kinetic energy from wind and convert it into the electricity through rotating blades. Uh, for example, if we see the example of dams, we store the water into the dam. When water fall down, then potential energy convert into the kinetic energy, and then high pressure of water uh, put into the turbines, then shaft rotate, and these turbine connected with generator, then generator generate the electricity, and then more we use this electricity. And hydroelectric power plant, same as we discussed before. Energy storage technologies, this is a same how we can store the energy. Okay. The next is energy management. How we can manage the energy. Energy management play a critical role in optimizing energy resources by improving efficiency. But mean we uh, improve the efficiency, we can manage. the energy, reducing waste, maximum reduce the waste products, and maximize okay. It involves the strategic planning, implementations, and monitoring of measures to minimize energy consumption, minimize the energy consumption, lower cost, disposal lower, and enhance sustainability across various sectors, including industry, building, transportation, and utilities. Energy management help organizations and communities achieve their energy goals, comply with new regulations, mitigate environmental impacts, and enhance in a rapidly evolving energy landscape. Um, Nowadays, different challenges we face. So, first challenge is climate change. Climate change, we see that our climate day by day change. So, the urgent need to mitigate greenhouse gas emission and transition to low carbon energy systems to address climate change impacts such as rising temperatures, weather change, uh, and the glaciers melts, and when due to the melt of glaciers, the water of the rivers rise up. Okay, then energy security. Okay, ensuring reliable and energy supply chain in the face of geopolitical tensions, resource constraints, and natural disasters that threaten energy infrastructure and discrete energy access. Environment impacts. Minimize environmental degradations, air and water pollution, habitats loss, productions and consumption activities, infrastructure modernization, upgrading aging energy infrastructure, enhancing grid and integrating smart grid technology to accommodate increasing electrification, renewable integration, and demand side management. Net policy and regulatory uncertainty. Policy and regulatory we discussed before the slides. Then again we discuss navigating complex and involving policy landscape, regulatory framework, and marketing dynamics that impacts investments, project finance, business models in the energy sector. Actually, policy and regulatory are very important when we design anything. When we design any structure of the project, then uh, policy and regulatory is important. A human capital development, developing a skill workplace, fostering innovation, promoting emerging energy technologies and practice. So next is uh, okay. For before we discuss the challenges, so then next is opportunity for growth and development. What opportunity we can growth and development in energy engineering, renewable energy expansion, energy efficiency improvements, innovative financing models, digitalization and automation, circular economic solution, education and capacity building. Some points we discussed already, but for your easier, again, uh, I can tell you in simple wording. Renewable energy expansion mean renewable energy sources such as solar, wind, hydro, and geothermal to reduce carbon emission, enhance energy security, and create and create jobs in the clean energy sector. Next, energy efficiency improvements mean reduce energy waste, lower cost, and improve productivity across various sectors, including buildings, transportation, industrial, and agriculture. So next is innovative financing models, such as green bonds, carbon markets, public private partnership, uh, investment in clean energy projects and infrastructure. Next, digitalization and automation mean data analyzing and automation to optimize energy systems, circular economic solution. This is such as resource recovery, waste to energy conversion, closed loop energy to minimize waste generation, maximize resource efficiency in energy production and consumption. Education and capacity building, investing in education, training, and capacity building to develop a skilled workforce, foster innovations, and promote lifelong learning in the field energy engineering. I think you understand. So next is a future trend in energy engineering. What is the role of energy engineering in the future? So, first, emerging technology, the innovation. What technologies emerge nowadays? Advanced energy storage. First, smart grid and microgrid technologies, electrification of transportation, hybrid energy systems, renewable energy innovation, carbon capture, utilization and storage, artificial intelligence are of these technologies emerging. Okay, so we tell you our points introduce very small line, advanced energy storage, development of next generation batteries, hydrogen storage systems, and grid scale energy storage solution to enable greater integration of renewable energy sources and enhance grid stability. Uh, small, smart grid and microgrid technology mean this is um, advanced sensors, automations, and digital communication technology, electrification of transportation, uh, acceleration of electric vehicle, development of fast charging infrastructure, and integration of vehicle to grid technology to support the transition to clean and sustainable transportation system. And hybrid energy systems is integration of multiple energy sources and technologies such as SEM for solar PV, wind turbine, energy storage, and demand side management to create a hybrid system to optimize energy generation, distribution, and utilization. Next is renewable energy innovation. We discussed already, but again, continue advancements in solar, photovoltaics, wind turbines, hydroelectric power, and other renewable energies technology to improve efficiency, reduce cost, and unlock new development opportunities and diverse geographic regions and environmental conditions. Carbon capture, utilization, and the storage, these are very important. This is a technique we capture the carbon dioxide and we store carbon dioxide because uh, when, for example, coal is burned in industries, and when coal is burned, then carbon dioxide emit into the environment. This when carbon dioxide release into the environment, then this is very harmful for our environment, all living things. So carbon capture and storage is a technology. We capture the carbon dioxide and then we store. Uh, Before burning the coal, we remove the carbon dioxide. This is a option. And second, when we burn the coal, then we remove the carbon dioxide with the help of carbon capture and utilization and storage process. And AI, uh, integration of AI and machine learning algorithms into energy system for predictive modeling, optimization, decision supports in energy planning, operation, and maintenance. Okay. Okay. Second, predictions for future of energy engineering, decentralization and resilience, digitalization and connectivity, electrification and renewable and integration, sustainability and climate action, collaboration and innovation, energy accepts equality. Some points we already discussed, but before discussed, but now we again discuss. Number first point is decentralizations and resilience. Energy system will become increasing decentralizations and adaptable to diverse environmental and operational condition with a greater emphasis on local generation, distributed energy resources, and community-based energy in initiatives. Second is digitalization and connectivity. Digital technology, data analytic, and internet of things devices will play a central role in optimizing energy performance, improving assessed management, and enhancing customer engagement in energy market. Electrification and renewable and integration we also discussed, but again, electrifications of end use sectors such as transportation, heating, and industrial process will accelerate driving increased demand for renewable energy sources and necessarily enhance grid flexible and storage capacity. Uh, Next is sustainability and climate action. Energy engineering will sustainability, environmental free, and climate action with a focus on achieving net zero emissions, enhancing energy efficiency, and promoting equitable access to clean and affordable energy for all. Next is uh, collaboration and innovation. Collaboration between governments, industries, acad- academic, and civil society will be essential to drive innovations, scale up green energy development, and address global energy challenges in a cooperative. Next and last is energy access and equity. Effort to expand energy access, particularly in communities and developing region, uh, with a focus on deploying decentralized and off-grid solution, improving energy affordability, and local communities to participate in energy decision making process. Thank you. So this lecture is closed. Uh, you can ask me any question. Hello.
Can you please elaborate the renewable energy and how we can relate this with the environment?
Hello. If you if you want any question, then can you ask me any question?
Hello. Hi, ma'am. Can you listen me? Hello. 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 Hello.
Okay. You cannot ask me any question.
Hello. Can you listen, please? Hello. Hello.
Okay. Uh,
Am I audible?
Muhammad Asif,
Yeah.
you want me any question?
Yeah. I would like to put your attention on the renewable energy
But I cannot hear
and
your
how we
voice.
renewable energy and how we correlate it with the environment and sustainability. Hello.
Okay, we meet after a 10-minute break.
You can hear me now?
The voice is okay?
Okay, welcome back. Again, I ask if anyone want me any question, then ask me. Muhammad Khalid Nasir, can you want any question? Uh, uh, can you hear my voice clearly? Uh, Okay, no, any question? No, any question? So I finished this lecture. No question? Okay, over this meeting. Goodbye.